On April 8, 1941, at exactly 2:35 in the afternoon, a massive aircraft rolled down the runway at Nakajima's test facility just outside Tokyo. The plane was enormous, over 100 feet long, with a wingspan stretching nearly 140 feet. 4 engines roared with a deafening thunder as it lifted into the humid Japanese air. Engineers from the Imperial Japanese Navy stood watching, their faces tight with anticipation. They had spent 18 months building this bomber. They had spent $950,000 buying the American airliner it was based on. They had even faked a crash to hide what they were really doing from the rest of the world. And now, finally, their creation was airborne. The pilot pushed the throttles forward. The aircraft climbed slowly, too slowly. The engines strained against the weight, and the controls felt sluggish and unresponsive. Something was wrong. In truth, something had always been wrong. The Japanese had acquired American technology, reverse-engineered the most advanced airliner in the world, and transformed it into what they hoped would be a strategic bomber capable of striking targets across the Pacific. Instead, they had built one of the worst heavy bombers in aviation history. This is the story of how Japan bought America's rejected airliner and turned it into a spectacular failure. It is a story of espionage, deception, engineering hubris, and the dangerous assumption that copying someone else's work is the same as understanding it. It is a story that begins not with war, but with the golden age of American commercial aviation. The year was 1935. Commercial aviation was transforming America. Airlines were expanding routes, and passengers were growing more confident in air travel. The Douglas Aircraft Company had just introduced the DC-3, which would become the most successful commercial aircraft of its era. But even before the DC-3 entered service, the airlines were already dreaming bigger. William Patterson, the president of United Airlines, approached Douglas with an ambitious vision. He wanted an aircraft that would make the DC-3 look like a relic. Patterson envisioned a 4-engine airliner capable of crossing the entire continent without stopping for fuel. It would carry 42 passengers in daylight service or 30 in sleeper berths for overnight flights. It would have pressurized cabins so passengers could fly above the weather, and it would have air conditioning for comfort. It was to represent the absolute cutting edge of aviation technology. The proposal was audacious. No airline had ever operated a 4-engine land plane for commercial passenger service. The technology Patterson was describing barely existed. Building such an aircraft would require solving engineering problems that had never been tackled before. The risks were enormous, and the costs would be staggering, but the potential rewards were equally impressive. Whoever built the first successful 4-engine airliner would dominate commercial aviation for a generation. Douglas was intrigued, but cautious. They knew the challenge would stretch their capabilities to the limit. They agreed to proceed only when other major airlines expressed interest. American Airlines, Eastern Airlines, Pan American, and TWA all joined the consortium. The engineering challenge was immense. Douglas assembled a team led by Arthur Raymond, who had led the DC-3 program. They faced problems that had never been solved. How do you build a wing strong enough to support 4 large engines while remaining light enough to fly efficiently? How do you design landing gear that can handle an aircraft weighing over 60,000 pounds? The team worked for 2 years, producing over 8,000 drawings. They built a detailed wind tunnel model and conducted over 800 separate tests. They used over 1 million rivets to assemble the prototype. The total engineering effort was measured at 500,000 man-hours, an unprecedented investment for a commercial aircraft in the 1930s. What emerged was called the DC-4. It was the first large aircraft with tricycle landing gear, meaning it sat level on the ground rather than tilting back on a tail wheel. This change had profound implications. Passengers no longer had to climb uphill to board, and cargo loading was easier. The nose wheel design would eventually become the industry standard. The wing was massive, spanning over 138 feet. 4 Pratt & Whitney engines were mounted on the wings, each producing 1,450 horsepower. The tail was perhaps the most distinctive feature, featuring 3 vertical fins. This was chosen so the aircraft could fit inside existing hangars across the country. Inside the fuselage, the DC-4 was designed for luxury. The cabin was wider than any previous airliner, allowing for comfortable seating and fold-out berths for overnight flights. Air conditioning kept the cabin comfortable regardless of the outside temperature. The flight deck was equally advanced, featuring power-boosted controls to reduce the physical effort of the pilot. On June 7, 1938, the DC-4 prototype was ready for its first flight in Santa Monica, California. At the controls was Carl Cover, Douglas's chief test pilot. He had piloted the first flights of the DC-1, DC-2, and DC-3. Now, he was adding another milestone to his legendary resume. The flight lasted about 45 minutes and went without incident. Testing continued through 1938, and the DC-4 was officially certified for commercial operation in May 1939. The prototype was turned over to United Airlines for in-service evaluation. This was the moment of truth. However, daily airline operations revealed serious problems. The DC-4 was simply too complex for practical use. Its sophisticated systems required specialized maintenance that most airports could not provide. Mechanics were baffled by the complex electrical and hydraulic circuits. Most importantly, operating costs were far higher than projected. The aircraft consumed fuel at alarming rates, and its range was less than promised because of its excessive weight. One by one, the airlines delivered their verdict. Pan American and TWA had already withdrawn to invest in the Boeing 307 Stratoliner. Now, United, American, and Eastern reached the same conclusion. The DC-4 was impressive technology, but it was not suitable for commercial service. It was too expensive, too complicated, and too unreliable. Douglas faced an embarrassing failure. They had invested years of work and millions of dollars in an aircraft no one wanted. The DC-4 prototype sat at the factory like a monument to overambition. Douglas executives had to decide what to do. They decided to design a new, simpler 4-engine airliner and sell the original prototype to recover some costs. A buyer appeared in late 1939 from an unexpected direction. Representatives from Japan's Mitsui Trading Company approached Douglas. They wanted to purchase the DC-4 for Japan Airlines. The DC-4, despite its problems in America, represented technology far ahead of anything available in Japan. Douglas saw an opportunity to cut their losses and sold the plane. What Douglas did not know was that Japan Airlines was serving as a front for the Imperial Japanese Navy. The Navy had never attempted a 4-engine design and believed the DC-4 offered a shortcut to building a long-range strategic bomber. They planned to buy the aircraft, study its construction, and apply that knowledge to their own military designs. In late 1939, the DC-4 was disassembled and shipped to Japan. Along with the aircraft, Douglas provided all the engineering data files, drawings, and even the wind tunnel model. A team of Douglas technicians even traveled to Japan to help reassemble the aircraft, unknowingly teaching potential adversaries how to build heavy aircraft. Once reassembled, the DC-4 wore the colors of Japan Airlines, but it never carried a single paying passenger. After a few test flights, it was quietly transferred to the Nakajima Aircraft Company. To explain its disappearance, the Japanese government fabricated a story that the aircraft had crashed into Tokyo Bay and was lost forever. At Nakajima, engineers methodically dismantled the DC-4. They measured every dimension and analyzed every system. What emerged from this study was the Nakajima G5N, designated by the Navy as the Experimental Type 13 attack bomber. The Japanese gave the aircraft the name Shinzan, meaning deep mountain. The G5N borrowed the wing and tricycle landing gear directly from the DC-4. However, the fuselage was redesigned with a massive bomb bay and defensive armament, including 20mm cannons. For power, Nakajima chose their own Memori engines, which were supposed to be more powerful than the original American engines. The first G5N prototype flew in April 1941, but the test pilot's reports were disappointing. The aircraft was too heavy, and the engines were unreliable. They overheated during climbs and suffered from excessive vibration. The G5N was slow, with a maximum speed of only 261 miles per hour, slower than contemporary American heavy bombers. The dream of a strategic bomber capable of crossing the Pacific was dying. The G5N could not fly far enough while carrying a full load of weapons. Nakajima built 6 prototypes in total, trying different engines and refinements, but the fundamental flaws remained. The aircraft was simply an overweight airliner straining against its own design. By 1942, the program was canceled as a bomber. However, the Navy refused to waste the airframes and converted them into long-range transports. The mighty bomber that was supposed to strike distant targets spent the rest of the war as a cargo plane, hauling supplies and personnel to isolated island bases. American intelligence eventually detected the aircraft's existence through aerial photography and gave it the code name Liz. They prepared for it to be a dangerous threat, not realizing that Japan had already abandoned its combat role years earlier. The intimidating 4-engine planes seen on Japanese airfields were actually just transport missions. None of the G5N aircraft survived the war. They were either destroyed in air raids or scrapped for materials as Japan's situation became desperate. The original Douglas DC-4E prototype was also reduced to scrap after the engineers had extracted its secrets. Today, the aircraft exists only in old photographs and technical manuals. The irony is that Douglas learned from the failure of the DC-4E. They went back to the drawing board and created a simpler, more efficient version that became the C-54 Skymaster. Over 1,200 of these were built, becoming the backbone of Allied air transport and later serving in the Berlin airlift. Japan, however, had copied the failure without understanding the lessons behind it. They spent nearly $1 million in years of effort to produce a handful of transport planes. This history serves as a reminder that the physical artifact is only part of technology. The experience and wisdom gained through the design process are what truly matter. Douglas understood why the DC-4E had failed, allowing them to create a masterpiece next. Nakajima only saw the final product, leading them to repeat the same mistakes. The story of the Deep Mountain remains a cautionary tale about the limits of imitation and the importance of original engineering. If you enjoyed this deep dive into aviation history, please like this video to help us share more forgotten stories from history. Don't forget to follow to stay connected with these untold narratives. We would love to hear where you are watching from. Leave a comment below to join our global community of history enthusiasts. Thank you for watching.